Hello and welcome to Skill Builders. This is the second tutorial concerning Oracle Solaris 11 kernel zones. Part 1 introduced you to zone configuration and installation, and this part 2 tutorial will concentrate on reconfiguring kernel zone resources. Just to explain, if you have just joined this tutorial without seeing part 1, Solaris is an operating system owned and developed by Oracle, and both versions 10 and 11 being the current version, support lightweight virtual machines called zones, otherwise known as containers. Up until now, zones have depended entirely on the kernel of the host system known as the global zone, but since Solaris 11.2 we can have kernel zones which can run entirely using their own kernel, just like any other normal operating system. Okay. As a reminder of the installation steps we took in the part 1 tutorial, we can see on this page that first of all you have to establish whether the machine supports kernel zones or not, and the way to do that is to run virt info, and there we can see kernel zones are supported. If that doesn't come out, then it's tough luck because you won't be able to create a kernel zone. And as we explained on the previous tutorial, you need fairly hefty SPARC hardware in order to support zones, the kernel variety being anything between a T4 Oracle server and a T7. You can also support kernel zones on Intel architecture. Having established that we can actually use the kernel zone, we can then configure it. And on the left hand side you can see the configuration steps we took to create the zone, and then the zone ADM command to install it. So on this system I have a kernel zone installed, and if I run that zone ADM command I can list the current zones. Okay, my global zone is my host system, Kzone 1 is my kernel zone, and Apache is another lightweight zone, non-kernel zone, that I'm using to support the Apache web server. Okay, so let's move on and have a look. How do we know what a kernel zone currently is using in terms of resources? Well, there's a variety of ways. First of all, from the global zone we can do zone CFG -z, the name of the zone, and then export, and that will print on the screen the detailed configuration that is stored in etc. zones for that particular zone. And here we can see the amount of RAM, 4 gigs, and the number of CPUs, 4. Okay. Very shortly we're going to have a look at how that can be changed. Okay. Now we can also log into the zone . I'm just using the Z login command. Okay. And as I'm running as root on my global zone, I get in without a password. My zone is called Woody, as you can see, and I can use the normal commands such as PSR info, and I can see I've got 4 virtual CPUs assigned, and I can do things like PRT conf pipe into grep mem, and I can see that I've got 4 gigabytes of RAM installed as well. But what if I want to change those resources? Oh, by the way, I'm also going to show you how to do networks. So I can, in the zone, I can do dladm show -link, and I can see that we currently have 1 network interface running. So very shortly I'm going to add another network interface to the zone, and I'm going to make some changes to the memory and the CPUs as well. When zones are running, you can use the zone stat command to display information about zone resources, and you would do this within the global zone. And the example there on the left hand side is running zone stat at an interval of every 5 seconds. I can show you quickly if I exit from the zone, clear the screen, and then run zone stat 5. I'll get some zone information coming out every 5 seconds. There are other options to zone stat. For example, I can do zone stat -z and specify a specific zone. Okay, and that gives me a bit of a clue as to the resources that are currently being consumed. Okay. Now, as you can see, the zone resources are specified in the zone configuration, which is stored as an XML file under etc. zones, and that information is called persistent storage or stable storage for the zone. Okay. Now we can change that by using the zone CFG command, but we may have to reboot the zone in order for that to take effect. There are some resources that can be set dynamically, so you can apply them to running zones. Okay. For example, CPU and RAM can be changed in a normal lightweight non-global zone, but unfortunately not in a kernel zone. But we can do things like adding a network device. Okay. Now we can change the resources, but we need to do it persistently, and then we need to reboot the zone. Okay. So let's go through an example. Okay, go into zone config, zone CFG, and I'll get a prompt. Bear in mind I'm doing this on the persistent storage and it won't affect the running zone. Select cap memory, and then I can type info to see what the current setting is, 4Gs, and I'm going to change it. To 6Gs. Do an info again. End to close that little section. Verify. Everything's good. Okay. I could also change CPUs in a similar fashion. Okay. Having verified, I'm going to commit and then exit. So if I do zone CFG -z k zone 1 export. Okay. The information has changed. There you can see physical is now 6 gig, but the zone hasn't yet used any of that, and I would need to do a reboot to bring that into effect. So why don't we do that? Okay, if I zlog in, I'll log into the console using the -C option, and then we can watch the reboot occurring. Okay, just to show you, in case you're wondering, the memory is still 4 gig. So if I reboot, okay, being a kernel zone, it will probably take a little bit longer to reboot than a normal non-global zone that doesn't have its own kernel. Yeah. And off it goes, rebooting again. Any second now we should be able to log in once again. The send mail message is because I don't have DNS running and I don't have a fully qualified host name, which sendmail doesn't like. So let's log in again, and let's do the part2 command again. Now I've got 6 gig, so the zone configuration required that I reboot the machine to do that. That's not always the case. If we move on, let me show you how I can actually add to a running zone. So Woody is running. I'm going to exit from the console, back to Buzz, which is my host global zone, and I'm going to do a zone CFG minus Z K zone 1 minus R, which will allow me to operate on a running zone. And I'm going to add another network interface, which is known as an ANET. It creates something called a virtual network interface, or VNIC. Okay, I've already got a VNIC with an ID of 0, which I showed you earlier. Now I can do a set ID equals 1. Not strictly necessary, but this will come up as net 1. The existing one being net 0. And now, if I do a commit, that has actually changed the running zone. It hasn't changed the persistent storage. Okay. Now, if I export, okay, there you can see the currently running configuration. And if I exit and go back into my K zone 1 again, to a DL-ADM show link, and there we have it. We have a new net 1. Okay. Now I would have to make a change to the persistent storage. Let's come out of there. And I would have to zone config without the minus R. Okay. Now I've only got one ANET ID 0, and I can add ANET set ID equals 1 and verify, commit to storage, and then exit. Okay, and then if I do zone CFG minus Z K zone 1 export, I've now got another network address in permanent storage. So my changes will now persist when I reboot the zone. Okay. So unfortunately I can't change things like RAM, and I can't change CPUs with a kernel zone. I have to reboot, but I can do things like add a network interface, and I can add other hardware as well if I need to. Now, what I could have done instead of what I did, in that I didn't need to change the running zone, I could have changed the persistent storage, as in the example that I just did. Okay, and then rather than applying to the running zone, I can do a zone ADM minus Z Apache apply, which would then have applied the persistent storage to the running zone. If I changed aspects like the ANET or added an ANET, those things would be applied. But if I did things like memory and CPU, nothing would happen. As you can see from the example here, zone ADM minus Z, K zone 1 apply, it says nothing to apply because it can't do it. There's quite a few other options. By the way, ordinary zones, non-kernel zones, can have RAM and CPUs dynamically changed. And there's a very good documentation for Oracle Solaris and kernel zones. And there's a reference there at the bottom of the page, which you can easily Google, which will show you all the different options that are possible. Okay. Bear in mind, just another reminder, that changing things like CPUs in zones may contradict Oracle database licensing, and you'd be well advised to download this article that I'm showing you here, this PDF, which is called Hard Partitioning with Oracle Solaris zones, which will give you some examples about to show what Oracle will accept as ways of setting CPUs for Oracle licensing purposes. Okay. One last thing, just a reminder that I went through on the previous tutorial. You may need to put a little kernel tweak in, okay, to set a limitation on the ZFS ARC cache. And there's some information here. Just as an example, you would create a file, a text file, in etc system.d. Any text file name will do, containing that parameter, set user reserve hint pct equals, and then the percentage of RAM that you want to make sure is available for your applications. Otherwise, ZFS tends to use a lot of free memory and may not release it quickly enough and cause a few headaches with memory management. Okay. There's a very elaborate and detailed document available from Oracle. Log into my Oracle support and look for that doc ID 1663862.1, and that will explain everything in fine detail. Thank you very much for looking at this tutorial. I hope you've learned a little bit from it, and we look forward to seeing you, or we look forward to the fact that you may join us for another tutorial a bit more down the line, when we'll be looking at kernel zone shared storage. And this has been brought to you by Skill Builders, who are experts with Oracle databases. Thank you very much indeed.